Okay, lesson 9. Now we're going to be talking about the segments in the circle. We're not going to be concerned today about the arcs and the angles. We're just going to talk about the relationships between the segments that happen in a circle. So the first thing we have is intersecting chords. And I bolded in red the special circumstances. There are 3 of them. And I also boxed the whole theorem kind of in a box for you to find it. Okay, so the product of the segment of one chord is equal to the product of the measures of the segment of the other chord. So A times B, you have to multiply them, equals C times D. That's kind of weird if you think about it, but I want to tell you where it comes from, because some of you are, maybe you're a future math teacher and you want to know where it comes from. This comes from a proportional relationship between the similar triangles that would be there if AD and CB were drawn in. So now you see how you have 2 triangles here, and they are similar to each other. How do I know that? Well, to be similar, they have to have congruent angles. They have a pair of, let me just get it bigger for you here. They have a pair of vertical angles which are congruent. And then some of you may know why angle A is congruent to angle C, because they are inscribed angles that intercept the same arc. Okay? And same thing about D and B. So the triangles are similar to each other, and what do we know about similar triangles? Corresponding sides are in proportion. So that proportion would be A compares to D the way that C compares to B, and then if you just multiply cross multiply that, you would have AB, so the pieces of the segment itself. Each of the chords, it's broken into 2 pieces when they intersect, and the pieces are multiplied by each other. So AB comes from the same chord, DC, and CD are the 2 pieces of the other chord, AB. Okay, so this is how it looks when you do the problem. Now, I didn't do this one because I did a harder one for you, but I did do the setup. So I'm going to plug in all the information that they gave me, 12, 12, 3, and I'm looking for BE. Make sure you put the X on the correct piece that you're looking for. Now, so we're going to say, all right, we have this segment, this chord, the product of its pieces, so 3 times X. And then this chord, the product of its pieces is 12 times 12. If you solve that little first degree equation, you could get the answer to that one. Okay, so I did a harder one for you. I did this one where it's algebraically represented. Okay, I went through this, I put all these numbers in, and then I I set up the proportion. So 3 is here, times 3 is right here, times 2x plus 8, the other piece, they make one chord, and then 4 times 4x minus 3 makes the other chord. You never mix and match. They're from the same chord. Then I distributed on both sides, combined like terms, and solved. Okay, this one is a 1 step harder because there's no diagram, so draw your own diagram. When you do that, be careful that you correctly name things. So chords are A, B, and C, D, and they intersect at E in circle with center O. So the center of the circle is always off the chord, unless the chord is a diameter, and it would have told you that. Okay, so they intersect at E, so I'm going to name E first. One of the chords is AB. It doesn't matter which one you name AB, but make sure your A goes to B. You don't do A and then put B over here. That would be incorrect. Okay? And then CD is the other one. Now your diagram will, some of you will look exactly like mine because you'll look at mine and then make yours, but you could put those line segments anywhere you wanted in the diagram. Okay? You could put it And let's just move E down to where E is now. Okay, so it doesn't really matter. Then plug in your pieces. AE is 8, AB is 20. Now here's another hard thing. Look at what this problem did to students. AE is 8. AB is 20. Okay, this whole piece is 20. Right? So you have to mark the correct thing. And DE is 16. Well, this is clearly not drawn to scale, but of course, how could I draw it to scale if I drew it myself, right? Okay, to get this piece, I think most of you will know how to get this piece. If you know the whole thing is 20 and that piece is 8, you'll be able to get it. And you're looking for CE. Okay, let's go on to another relationship. Intersecting secants. Okay, so secants are line segments that are outside. They touch the circle in two places. So they're outside, they go inside, and sometimes they even continue and go outside again. But they intersect the circle in two places. Okay, the relationship here is something to memorize. I call it OW equals OW. And that's outside times the whole secant is equal to the outside times the whole secant. That's it. The outside piece, let me get a highlighter, multiplied by the whole secant is equal to this outside piece multiplied by the whole secant. The parts don't have to be equal to each other. One could be longer than the other, but their products are equal. Okay? The trick here is to make sure you have the whole secant. Sometimes you have to add two pieces to get it. Okay, that happened over here on number 5. They gave me 8, 4, 6, find JN. Right, so a lot of kids will do 8 times 4 equals 6 times X and get it wrong. That's an incorrect relationship. You don't have the whole piece for JL. How do you get it? I like to make this big bracket so I don't forget to get it. You'll see I have the bracket everywhere along. You're going to add 8 and 4 to get that whole piece. And I did that problem for you. I end up with 6 times X equals 8 times 12. I crossed out the 4 because I'm not using it in my formula. There's no 4 here. But the 4 is hidden inside the 12 because that's how I got the 12 by adding the 4 to the 8. If I didn't have that 4, I would not have been able to know how long the segment is to solve this problem. Okay, this one's a little bit challenging. I'm not going to do it for you, but I am going to show you that they're asking for OC, so they're asking for the radius. Okay, I marked the X where what I was looking for, but then I realized, okay, I have another radius here, and all together this is 4. Don't forget, in between these you're adding, so it's 4 plus X, or 4 plus 2X. Okay, that's your whole. So when you do this, and they didn't tell us the outside piece. So when we set this up, let's use this first piece AC. We have the outside is 4 times the whole, which is 4 plus 2X. I have to put a parentheses because I'm going to have to distribute there. On the other side, outside times whole, I'm stuck. I don't have the outside. I highlighted it pink for you. The outside isn't there. I know the inside is 6, and the whole thing is 12, so the outside must be 12 minus 6, which is 6. It's kind of a bad question because kids who mess this up, this would have been better if this was 7. Any number here would have been better than 6 because 6, if you put it here instead of here, you still get it right. Okay? All right, and then you do distribute, solve, and you can fix that one. Okay, last theorem, tangent intersecting with secant. Okay, now you're going to use the same procedure, OW equals OW. The only thing you have to remember is that the tangent never goes inside, so it's only outside. So outside and whole are the same. So you'll see some teachers say to their kids, okay, in this case you do outside times whole equals tangent squared. To me, that's just another formula you have to memorize. And honestly, you're not taking the Regents, so you don't have to memorize them, but I want you to know how to do these for your ACT, SAT, PSAT. Studying that formula is not necessary. All you have to remember is the whole tangent is outside. So outside and whole, when you're talking about a tangent, are the same. So it's AP. That's it. You don't have to memorize a whole new formula if you don't want to. Everybody knows that a tangent is only outside the circle. So the outside portion of the tangent is the whole thing. The secant, on the other hand, has an outside portion and an inside portion. So the whole you would get the whole by adding outside to inside. For the tangent, the outside portion added to 0, because nothing goes inside, gives you the outside portion, the whole portion. So outside and whole are the same thing. Here's an example. We're looking for the length of the tangent. They tell us that PB is 4 and BC is 5. So use your math teacher bracket. You always need the whole piece. So that's where this came from. I added 5 and 4. There's no 5 directly in my problem, but it's hidden in there in the 9. Okay? That's where the 9 came from. Without the 5, I couldn't have gotten the 9. Couldn't have solved the problem because I would have had 2 variables. Okay? But some of you are going to write 4 times 5 equals x squared, and you're going to get the problem wrong. So make sure you're remembering ow equals ow. That's the key here. Okay? All right, and there's a couple more problems for you to practice, and then there's a homework sheet. And you have 2 days to do it. I hope all is well. As usual, if you need my help, please email me your questions, and we'll get on to Remind or a chat. Okay? Bye. Have a good one.